Tonight I'm having a look at this NAD amplifier that I've just taken the cover off it, and it's got two blown fuses, so I'm going to have a quick look to see if I can work out what's wrong with it. NAD, or New Acoustic Dimension, were quite popular in the 80s, and they're still going now actually today. Sort of minimalist amplifier, designed for sort of good sound quality at a budget price. They've done a lot of things, a lot of innovative device options, and one of them was the soft clipping that you see on the front here. This front soft clipping is basically a limiter switch that prevents the amplifier from driving hard into clipping. I was going to demonstrate this as this amplifier works. I've just plugged it into the variac because of the blown fuses. I don't want to turn it hard on. I've replaced the fuses with higher current fuses, obviously because I haven't got the right fuses available, but that doesn't matter because I'm winding it up slowly anyway. I can keep an eye on the current. It uses the traditional Class AB amplifier output stage, using TO3 devices and the classic 2N3055s and the complementary MJ2955s. I do believe somewhere I've got in my collection some what they call PMP3055s, which was made by RS Components, and obviously electrical complementary to the 3055, which would do as a good substitute. I've got a feeling it's got an output stage failure because the way the fuses have blown, but I was going to wind it up this evening and see if I can get any life out of it at all. So here we go, wind up the power slowly, let's see if we get any life. Straight away I've got quite a loud hum. I'm going to disconnect speakers so I'm not putting any DCs to speakers, increase the power. I've got drawing quite a lot of current. You see straight away, you see that fuse glowing red hot? So we've got a short on the more than likely an output stage. So the next step will be to strip the amplifier down and remove the output transistors and check them for collector emitter shorts particularly. If the collector emitter shorts are clear, then you need to start working back through these drivers transistors here. You've got one here, and then you've got the lower signal drivers here. But the most likely fault will be these drivers here. This transistor here controls the biasing. This one here, and then you've got the pre-drivers to the 3055s and MJ2955s. So it should be a fairly straightforward fix. So what I'll do next is I'll whip the base off it, and see if I can do an in situ collector emitter diagnosis and see if there is actually a short circuit on the output stage. So let's go and see what happens there. Okay, here's the underside of the NAD. Pretty sort of crude wiring really. There's no obvious signs of any burning or anything. And here we have our output transistors. You see here the two screws that secure the transistors down, which aren't particularly tight, which can also cause a problem. So you've got the collector connection here. That's the emitter, that's the base, and it's the other way around on this one. That's collector, emitter, base, and likewise on this side. I don't think it's had any repair work, but this is the problem. You see these transistors, as they get warm, they all the insulators relax and things, and you find that the transistor actually hasn't got the same thermal conduction as it had when it was new or when it was first assembled. So what I'm going to do, I'm in continuity mode now. I'm just going to do a collector emitter short test on these transistors. I can do this one-handed. So we're on the collector now. That's the emitter. Showing dead short. So that's collector and the emitter on this side. That one's showing dead short. I haven't got the circuit diagram with me, but as far as I'm concerned, this shouldn't show a dead short across the collector emitter. There you go. See that channel? Channel's good. So more than likely, yeah, that channel's good, this channel's bad. So more than likely what's happened is the whatever channel this is, the left or the right, has someone's stuck a short circuit across the amplifier, or driven it into sort of like a 1 ohm load or something stupid, and then basically what it's done is it's blown the transistors up. So what you need to do now, and that's quite an easy test, you know, you should be able to, on a bipolar output stage, you should be able to do a collector emitter short, test to see if there's a collector emitter short, because if you've got blown fuses, there's a short across the line.